Hi, my name is Jailton. I am a PhD student from Federal University of Minas Gerais, Brazil, and now I'm going to present the research paper Identify Unmaintained Projects in GitHub. Open source software has an increasing importance in modern software development. GitHub is the most well-known example with 85 millions of public and private repositories, 28 millions of developers, and 1.8 million of organizations. However, GitHub projects are frequently abandoned by the developers. So, why do open source projects fail or becomes abandoned? In our previous work, we provide a set of 9 reasons for the failure of open source projects. The top 5 most common reasons are usurped by competitors like Apple or Google, uh, obsolete when the functionality of the software is not more necessary, and the lack of time, the lack of interest of the developers, and because of outdated technologies. Today, GitHub does not include clear data about the project status in terms of maintenance activity. What are the risks of using GitHub project? Is it an active maintenance? On here we have an example of a project with 60,000 of stars and almost 3,000 of forks. So do you have any hesitation to use this project? Of course not. After all, it has more than 16,000 of stars. However, the last commit of the project was on 7th of October in last year. And now, do we work choose it or not? So, our goal is to propose an approach to identify GitHub projects that are not actively maintained. So, our goal is to propose an approach to identify as soon as possible GitHub projects that are not actively maintained. However, by our definition, unmaintained projects do not necessarily need to be dead, deprecated, or archived. And how we can do that? So, to reach this goal, we build a machine learning model. First, we create a dataset with 1002 open source projects hosted in GitHub. This dataset is composed by 754 active projects that have one release last month when we collect the dataset, and 248 unmaintained projects that are composed by 104 abandoned projects published on FSE paper and composed by 144 archived projects. Finally, we use the Hunt-Force algorithm. In total, we consider 30 features that are the number of forks, open issues, closed issues, open pull requests, closed pull requests, merge pull requests, the number of commits, the number of max date without commits, and max contributions by developers. Next, we use the number of new contributors and the number of distinct contributors, and também and the the number of projects created by the owner and the number of commits. Next, we derive temporal series of feature values which can be used by a machine learning algorithm to train in the project evolution. This figure shows the feature collected during 24 months in 3 months intervals, counting from the last commit. In this case, we collect 8 data points for each feature. Next, we use the hand-force algorithm with 5-4 stratified cores validation to evaluate the model effectiveness. And finally, we perform 100 of experiments. This table shows the average of the results by hand-force algorithm for different numbers of periods and intervals. As we can see, hand-force has the best results in bold when the features are collected during 2 years in intervals of 3 months. In this scenario, accuracy is 0.92, the precision is 0.86, the recall is 0.81, the if measure is 0.83, the kappa is 0.78, and AUC is 0.88.